Question 1.1, using figure 1, which one of the following statements is true? Showed one circle in only. So figure 1, you've got a map of the world and the different plate margins or plate boundaries on. So the answer to the first one is C. There are many active volcanoes around the edge of the Pacific Ocean. So we've got the name of the ocean there. The volcanoes are the black dots. So are there a lot around the edge of the Pacific Ocean? The answer is yes. So the first one is 1C. 1.2, describe the movement of plates along plate margin X. So where is X? It is here. So we'll have a look at the margin. That line means it's a destructive plate margin. So can you describe how the tectonic plates are moving? So you need to remember what that is. And all it is when plates go towards each other. So looking at the mark scheme, simply by actually just saying that, we'll get you the mark. Plates come together or converge or collide. You can go a bit further, although it's not essential for this one because it's only a 1 mark question. But you could say, as the plates meet, one plate, often the oceanic plate, is pushed under or goes under, or key term is subducted under the continental plate because it is heavier. That will be plenty for 1 mark. The final one in this section is question 1.3. You've got another figure this time, figure 2. This is Iceland, and the plates, you've got North American plate moving to the west and the Eurasian plate moving to the east. And again, it's a multiple choice one. Using the figure, how long will it take for the plates to move 100 meters? So it's a little bit of maths to do. If you can't do this on your fingers, then obviously you are allowed a calculator for all your geography tests. So it says here they're moving 2.5 centimeters every year. So times it, I'm just going to work out how long it would take to go 100 meters. And the answer would be D, 4,000 years. 1.4, using figure 2 and your own understanding, suggest how plate movements cause tectonic hazards in Iceland. So we know we're going to have to use the figure. We don't really have to evaluate this question, although it's a 6 marker. You just really got to explain the causes of what they've called tectonic hazards. So these are our earthquakes and volcanoes. So looking at the figure, there's loads of things we can use here in our answer to help us. You've got the name of the plates, North American plate, the Eurasian plate. We can use the compass directions for general patterns. We can work out how much the plates are moving apart 1 year. So potentially we could do a little bit of maths and work out in 10 years or 100 years, whatever it might be. You've got the capital marked for as Reykjavik. You've got a scale bar. So we could maybe use that to say roughly where these volcanoes are located, maybe in comparison to the capital city. So there's loads on there. Now, when you talk about causing volcanoes and earthquakes, I would always start with how the tectonic plates move to begin with. So there's a few things in the mark scheme. First of all, you've got something called ridge push. This is a theory whereby as magma from this part here rises to the surface, it basically pushes the tectonic plates apart from each other. So it will force the North American plate to the west and the Eurasian plate to the east as the magma rises to fill the gap. That's ridge push. Slab pull. This is the idea that in other parts of the world where plates are going towards each other, they will subduct, they'll go underneath. And once they start going underneath, gravity will then take hold and drag the rest of the slab or the tectonic plate with it. You can also talk about convection currents. We thought for a number of years that this was the main reason why tectonic plates move rather than these two here. And this is the idea that magma rises to the surface or close to the crust in the mantle, and as it starts to cool down, that magma will then eventually circulate back down into the lower parts of the mantle towards the outer core. So you've basically got these cycles And these cycles basically move the plates, not a lot, a couple of centimetres every year, towards and away from each other. Now, once you've explained all that, I would then suggest that you actually name this plate boundary and say that this is a constructive plate boundary. Constructive just means things are built. Construction, build, same thing. In this case, we are building volcanoes. So as the plates move apart, earthquakes can occur because the plates are moving. What it suggests in the mark scheme is the idea that earthquakes that occur because plates are moving or because magma is rising to the surface generally can be low magnitude, low strength, although it does say on here that they can be over 6 on the Richter scale, which is particularly, can be quite big. Also, you could then say, we get lots of volcanoes. You can actually count them: 1, 2, 3, 4, 5, 6. You've got about 7 volcanoes within the constructive boundary, because as the magma has risen up, it's cooled down. It comes to the surface, it then erupts, and they're your volcanoes. And then as the lava cools down, it will then turn into very gently sloped flat volcanoes called shield volcanoes that can spew out lava fairly regularly. So lots to go on there, but focus on the causes. Make sure you use information from figure 2 as well. 1.5, using figure 3, which one of the following statements is true? We've got to show one circle in only. So the answer is C here. The 15 hottest years were all recorded between 1995 and 2015. So let's just double check. The 15 hottest years are in the darker red colour. So these here. Are they all between 1995 and 2015? So 1995 is here. 2015, they're all in that section. So yes, C is the true statement. 1.6, give one natural cause of changes in global temperature. Okay, so we can be quite brief here, but we just need to come up with something that's not man-made that has basically changed the temperature of the world. For instance, how has it got hotter? Looking at the mark scheme, these can be really brief answers. We could say that the Earth's orbit changes. This is the path of the Earth around the sun. Every roughly 100,000 years, it goes from a circle to an oval shape. So you could just state that. You could say volcanic eruptions can change global temperatures due to maybe lots of carbon dioxide that is emitted out, which traps the sun's insolation or heat in. You could also say from a volcanic eruption, it gives out lots of ash, which blocks the sun's energy from actually reaching the Earth itself, which could cool us down. It's called a volcanic winter. Or you could highlight the idea that on the sun, you look close enough, there's lots of spots or dots. And the more dots there are, the hotter the sun is, because the sun is not a constant temperature all the time. So that could explain the change in global temperature. Just be careful, just say natural, so anything man-made, like the fact we are burning loads of fossil fuels for cars and factories, etc., you don't get the mark for. 1.7, give 2 pieces of evidence other than the change in global temperature that show that climate change has taken place. So I guess the biggest piece of evidence would be the fact that we know that ice is melting, particularly in the polar regions, the North and South Pole, which is an answer in the mark scheme here. You could say that we could look at the level of the sea, and we know that it's starting to rise. You could link the fact that there are more hurricanes now. Not only are they stronger, but there's a lot more of them as well. They're more frequent, which, as we know, the water for hurricanes to form needs to be particularly hot, 27 degrees plus. So this could also highlight the fact that if there are more hurricanes, the water is hotter, certainly further away from the equator, which can link into the fact that the climate is changing, getting hotter. You could also link into the idea of ocean acidification. Probably not the most obvious one, but this is the idea that if there is more carbon dioxide in the atmosphere, the seas and the oceans, they're going to absorb some of this as well, which is actually starting to turn things like the coral reef, starting to bleach them, which is basically killing them, turning them white and killing them, because the pH of the water is becoming a bit more acidic because of the pollution it's absorbing. You could accept other things that we've done in lesson as well, such as we can drill into ice and get what's called an ice core. You're basically looking for trapped carbon dioxide bubbles in the ice, because if there was more in the ice than there is now, that would suggest that the temperature of the world has changed over time. We've also looked at things like dendrochronology. This is the study of trees and tree rings. If rings are not the same shape, that would suggest that we've had some really long hot summers and some short summers as well, because each ring is a year of growth. Obviously, trees will generally grow during the summer months. We also talked about, we had a few abstract ideas about cave paintings and the fact that animals might become extinct or moved from areas, because if we look at the cave paintings and the animals that they have drawn are no longer alive or no longer in that part of the world, they might have moved because of the temperature. And again, a similar idea with fossils of animals in the ground or trapped pollen in ice as well. If those trees or animals are no longer there, then maybe the climate could have changed, and that might be a result. 1.8. Explain how the increasing use of fossil fuels and changes in agriculture may have contributed to global changes in temperature. It's a 4-mark question, so we need to develop our points on the use of fossil fuels and how agriculture or farming has basically led to the world getting hotter and hotter. So first of all, focus on fossil fuels. Fossil fuels are things like coal, oil and natural gas. The key phrase here is they give out greenhouse gases once they are burnt. For instance, carbon dioxide. And you could say simply there are more people in the world than ever before, and these people need certain things. A lot of people are getting these things, such as their own transport, cars, houses. So link those points in and say the more people in the world means there's more cars, which means there is more carbon dioxide being produced, and then just explain why that has changed the global temperature. So these greenhouse gases go up into the atmosphere, and basically they trap the heat or the sun's insolation into the earth. So the sun's rays come here, they bounce back, but because our atmosphere is really thick with these greenhouse gases, they keep the world hotter and hotter, and that's called the enhanced greenhouse effect. In terms of farming, well, you could say that on farms we've had this process, particularly the last few years in developing countries, of mechanization, which means there's more machines on the farms. Machines, to be powered, will no doubt have to burn some fossil fuels. Or you could say a lot of farms transport goods great distances. They might import or export their goods to other parts of their country or abroad. So you could link it into, again, the idea of more fossil fuels being burned because of the transport. Or you could appreciate and realise that a lot of agriculture is happening in places where there would normally be a big forest, such as a rainforest. And lots of trees are being cut down. This is called deforestation. Basically turn the forest land into farmland. Now, cutting down the trees is obviously bad because carbon is stored in trees. If there are fewer trees, there is less chance for the carbon to be stored, and it'll instead be in the atmosphere. So that would obviously increase global temperatures. Or you could also say that on a lot of these farms, we are rearing a lot of animals, such as cattle, such as cows. So the increase in meat or dairy production could also mean if there are more cows that there's more methane that's going to be produced will then go in the atmosphere and also increase global temperatures. 1.9. Using figure 4, describe the track of Hurricane Irma between the 6th of September and the 12th of September. So in terms of figure 4, this is it. You've got a map of the Caribbean and America, and then you've got the line, which is the path that the hurricane has taken. Now, what you've got to do for this question is you've just got to describe basically the movement and the path this hurricane has taken. So there's a fair bit of information here. In particular, you do have different colour circles, which is to do with how fast the wind was blowing at that certain points. But for this question, you don't talk about that at all. Not about the intensity, not about the strength. It is simply just the path. So if we have a look at the mark scheme, let's stop it. 1 mark for saying the hurricane had a change of direction, because you can see from where it started out in the Atlantic Ocean, it went west till this point here, just north of Cuba, and then it went north, or you could say northwest. It's a slight diagonal. So you could say, it had a change of direction, and then be specific. Use those compass points to then get that second point. You could also use, obviously, like the place names, like I've said. You could say it went west past Puerto Rico, Dominican Republic, Haiti, and then north into the United States of America. So as long as you use the evidence from here, and again, very similar to if you've got a graph, don't just say it went up. Try and break the pattern down. And in this case, we've got west and then we've got north. Just to reiterate, no credit for changes if you talk about the wind speed. That's not this question. 1.10, using figure 4, what happened to the wind speed of Hurricane Irma between the 8th and the 12th of September? So let's have a look up again. So we're looking at the dates here, the 8th of September, pointing to this one. So the wind speed was 252 kilometers an hour or higher. And then the 12th of September, it went down to 119 to 153. So this question is only 1 mark. So you could have just a very basic short answer, such as the wind speed reduced. It fell from a category 5. As I've mentioned, it dropped from over 152 kilometers an hour. Anything very similar to that is fine for your 1 mark here. Question 1.11. Give one reason why the wind speed of the tropical storm may change as it reaches land. So why does the energy and the wind speed of a hurricane get less and less as it hits land? So the main thing is to do with really the temperature, because hurricanes spin away from the equator, and in the northern hemisphere above the equator it spins anti-clockwise. So ideally we talk about the idea that as the land or water gets colder, there is less opportunity, and this is the key phrase, for less rapid evaporation, because that is what powers a hurricane. So if the water is, or the land is colder, there is less evaporation that's going to happen. You could also suggest that as the hurricane moves over land, and the key phrase here would be the friction of the land slows it down. And they've put the idea of the wind coming in contact with the land, or it says rough terrain, which could be things like mountains. They're going to slow the winds down. The key phrase is friction. I would encourage you not to sort of say the buildings slow the hurricane down or anything like that. It's really just the actual land itself, particularly if it's fairly high. 1.12. Assess the extent to which tropical storms have effects on people and the environment. Use figure 5 and an example you have studied. So what we need to talk about here is the effects of a tropical storm or a hurricane. And we've got to talk about the impacts on people, the impacts on the environment. we've got to use figure 5, which is a photograph of a Caribbean island, and we've got probably an extract from a newspaper at the top here, an example you have studied, which in this case would be Hurricane Katrina. Now, for this 9 marker, you've got to assess the extent. In other words, how bad are the effects on people and the environment? Now, in terms of the mark scheme, then, you don't have to necessarily use this wording, but this is the sort of thing that examiners are looking for, particularly in getting the level 3 answers, which is a 7, 8, or 9 out of 9. You've got to have this assessment factor in your question. So you could say, to what extent? You could say there's been to a devastating extent, to a considerable extent, to a slight extent, or limited, or words to that effect. But I imagine a lot of you would write here that actually there has been a huge impact on people and the environment. So you'll be saying to a greater extent. Now, in terms of the effects on people, these are just some suggestions on the mark scheme, and obviously link to Hurricane Katrina and this picture. But the effects can be short term, they can be long term. It's basically, you can talk about whatever you want as long as you link it to people. So first one, people being killed or injured. You can link this to the idea that people's families will be broken up, and it suggests talking about the shock would be valid. But I would always go with the idea that if lots of people die, you've got less workers in the area, and then you've got all those nice knock-on effects you could say about less workers, high unemployment, government gets less taxes, less money to spend on other things. You could have anything. Again, try and avoid just say buildings are destroyed. Break it down a bit. You could say houses, yes, are destroyed, but schools are destroyed, hospitals might be destroyed, offices as well, because then that gives you lots of avenues to explain those different knock-on effects. As we've seen with Hurricane Katrina, a knock-on, a secondary impact was the fact that aid came a few days late. So looting happened, people started to fight each other. If there was farmland, you could talk about the disruption of crops, or loss of livestock, the animals. You could talk about that perhaps in the Caribbean like this, it's not going to be the richest place in the world. So if you've got a lot of standing water that might be there for a while, then diseases may well fester in the water. Now, be specific. When you do use the figure, I would make it really obvious. If you're talking about an impact, you can say, well, in Hurricane Katrina, 1,800 people died. But then you also say, and this is also shown in figure 5, where there has been 8 deaths. So you're referencing both of them. So the examiner knows that, they can see it really clearly, and they can give you lots of marks. So we will probably be saying that the effect on people is really high. In terms of the environment, as we saw with Katrina, 80% of New Orleans is basically submerged underwater. So, you could think about that and think, well, what effect is that going to have? So it could be things like animals' habitats, coastal habitats disrupted, and then you've got, in nature, you've got food chains and food webs. So if some animals' habitats have been destroyed, either they will die or they'll move somewhere else, and that can have a real knock-on effect with the local ecosystem. So any of those points, not a problem. You could even suggest the built environment. So things like buildings and roads, you can, if you call them the built environment, and also get them into that point there, rather than talking about the effects on people. But just to be clear then, to get 9 marks here or close to it, your level 3 answers, they've got to be well developed, they've got to include impacts for people and the environment. You've got to use Hurricane Katrina, and you've also got to say to what extent. So there's quite a lot going on. So I encourage you to do this question first, maybe do a little bit of a plan before you start. Your first paragraph, ideally that's basically your conclusion. Use words like to a bad extent in maybe your opening sentence or two, and then your next couple of paragraphs are just basically explaining why you've come to that first conclusion.